Hey guys, in this video we are going to be looking at sort of a graphical analysis of what we did in the last video. Whereas in the last video we took an algebraic approach to finding the local extrema, whether it be minimum, maximums, and then also intervals of increasing and decreasing. We were given a function and then we had to use algebra to find those different points. Today we're going to be looking at the graph of the derivative. One thing that will be different on this is typically throughout all of your math life, you're used to looking at a graph of the function. Okay. However, on the AP test, they like to mix up a lot of different graphs. Sometimes they'll give you a graph of the function, f. Sometimes they'll give you a graph of f prime. And sometimes they'll give you a graph of f double prime, which we haven't talked about too much yet. So the first thing that is very important when you do any graphing problem on the AP test, where they give you a graph and they ask you a question about it, is make sure you have cemented in your mind, what is this a graph of? And all of these problems is going to be the same. It's going to be a graph of f prime. Again, on the AP test, it will be mixed up, so you won't always just know, oh, this is f prime or this is f. Your general assumption is that it's f. However, that isn't always correct on the AP test because they'll often say, sneak in, this is little f prime, and the only thing different is it's got that little, line up there, the little apostrophe, meaning f prime. So very important that we first recognize that before we do anything. This is a graph of f prime. Okay. So it works a little differently than the graph of f, which I'll explain to you here, but the question on this one is determine at any of the values at which the function has local extrema. Okay. Local extrema just mean local mins and maxes. So where does this function have local mins and maxes? Now we don't know the actual function, so the wrong answer, your first instinct might be to be, well, here's a max, and here's a min, here's a min. So boom, -6, -2, 3, and 7. That's it. However, again, this is wrong because this is not a graph of the function, not a graph of f. If that were a graph of the function, those would be correct. However, this is not. So let's think in different terms now. If we're looking for local mins and maxes, what does this mean in terms of the derivative? So this is the question you want to ask yourself. What does this mean for f prime? Okay. Let's start with local mins. So mins occur where f prime changes, and I always like to draw a little picture because I get confused too. Min looks like this, right? It's a little valley. So this occurs where f prime changes from negative, so we're going down, to positive. A negative slope to a positive slope. So f prime changes from negative to positive. That's where a minimum would occur. A maximum occurs. We got a hill. What's happening here is it changes from a positive slope to a negative slope, a positive to a negative. So f prime changes from positive to negative. Right. So when we look at this graph, we're going to be looking for sign changes of the derivative. Again, it's a little confusing how to interpret these. It just takes some practice. So how to look at this graph. If we're to sort of just follow this whole section is all at or below the x-axis. So what that section is telling us is that f prime is negative on that whole interval, meaning the function is decreasing. Even though it looks like it goes up, this is a graph of the slope, essentially. So what this is saying is, it's decreasing. If I kind of just made up a graph, it's decreasing, and then it doesn't decrease as much, and then it decreases some more, and then maybe not as much. And then at some point it levels off, and it starts to go up. And it's increasing, maybe not increasing as much, increasing. So this actually could kind of be a graph of that function. it's going down, 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 and then eventually it hits, which is going to be that point right there, and then it starts to go up, and this whole interval here is implying a positive derivative. In other words, the function is increasing. So it's increasing on this interval, decreasing on this interval. It does manage to hit 0 there. However, it doesn't change to increasing. It's just sort of levels out. So at this point, it is not a min or a max. However, that would be, we could say it's a horizontal tangent line. So that just means the slope is 0. So remember, this is all talking about the slope of our function. So in the first half there, the slope is all negative, and in the second half, the slope is all positive or increasing. So we only have one min or max in this because we only have one place where it crosses 0. So these local extreme are always going to occur at places where it crosses 0. Not just hits 0, but it has to cross 0. There's only one place there at 0, 0, and that is think decreasing to increasing. That's a min, right? Decreasing to increasing. I don't think we actually have to specify on this. It just wants the x values, whether there's an extrema. So there would be a relative min at x equals 0, but we just have to type in 0 for this particular question. You'll get the hang of interpreting these, but it is a little bit different at first. So again, we're just looking for where f prime changes sign. The only place that is the case is at x equals 0. All right, let's go ahead and try another one. Okay, the next one asks us for where is f increasing? So we're given, again, a graph of f prime, and we're asked a question about f. It's kind of opposite way of thinking in your mind. Generally, you're given the graph of a function, and you're asked about the slope. This time, you're given a graph of the slope, and you're asked about the function. So you got to sort of work that out in your mind. Again, it just takes practice. I have a mess up still. All right, so this is a graph of the function. So think about what the implications are. If a function is increasing, what is true of the derivative? If f is increasing, all that implies is that f prime is positive. If a function is increasing, f prime, or the slope is positive. If it's increasing, slope is positive, right? If it's decreasing, the slope, or f prime, is negative. It's kind of basic thinking, but it is hard because, again, it's giving you a problem in the reverse that you're used to thinking of in your mind. All right, so let's dissect this graph. On this whole section here, the function is decreasing because the slope is below the x-axis or negative, right? It's all decreasing on that whole thing. It doesn't matter the fact that it goes up and down. All we care about basically is that it's below the x-axis. And then it starts decreasing again over here because it goes below the axis. So again, so the increasing part is going to be from here to here. I know it looks weird because it's going down. Why would you say it's increasing? It is increasing. So those two intervals are increasing. So we're going to type those two intervals in. And I think Delta Math wants these put in brackets. In my opinion, I don't think they should be. I think they should be in parentheses because at the point, technically it's 0. But I think to type in your answer, I think they want it in brackets. So we're going to do brackets -1 to 4 as our first increase in interval, union 8 to 9 with brackets again. And let's submit that. There we go. All right, let's answer our next question. We're again given the graph of f prime. That will be true for all of these. But again, AP test will mix them up. Determine the values at which there's a relative minimum. So let's think, what does relative minimum mean? Draw a little minimum. That means that the derivative is changing from negative to positive. So f prime changes from negative to positive. So where does that occur on this graph? Well, let's look at the only places that it crosses 0 are the only possibilities. Okay, again, extrema only occur where this graph is going to cross 0. So these two are possibilities where it crosses. The other one at -4 is not a possibility because it doesn't cross. So these are only two possibilities. Let's think about what happens. Well, this is negative down here, and then it turns to a positive function. Up here, it's positive and switches to negative. So negative to positive, that's a min. Positive to a negative is a max. So we were looking for a minimum, so the only places there at x equals 1. Let's try another one. Where is the function increasing? Okay, let's think about what that implies for our derivative. If something is increasing, that means f prime is positive. So let's go just to highlight all the places where the derivative is positive. Again, this is the graph of the derivative. Don't fall into the habit of thinking, oh, it's increasing all the way from here to here, and it's increasing from here to here. That would be very wrong, right? That's the temptation, but don't do that. So increasing would just be any places where it's above the x-axis. So from here to here, it's increasing. From here to here, it's increasing. Those two intervals. And again, type them in with brackets. For whatever reason, that's how Delta Math wants it. 2 to 8. And there we go. All right, looks like there's one more problem type here. Let's go. So critical value. All right, that's a good one. So all the places where there's a critical value. Let's think about that. What that means for our derivative. Okay. So critical value. If you remember on the previous video, critical value are all the places where f prime equals 0, okay, or is undefined. All the places where f prime equals 0 or is undefined. All right. Critical values generally are places where there's mins and maxes. Minimum maximums always occur at critical values. Okay. However, not so you can think of it in this way. If you ever heard like the saying that all squares are rectangles, but not all rectangles are squares. If you've ever heard that before, it's kind of the same idea here. So you could say all extrema are critical values, meaning all of mins and maxes are critical values, but not all critical values are extrema. There you go. You can tell that to your parents tonight. All extrema are critical values, but not all critical values are extrema. What does that mean? It means all extrema are occurring at critical values. However, just because something's a critical value doesn't necessarily make it an extrema. So, critical value, let's just go circle on this graph all the places where the derivative is 0 are undefined. In this graph, we only have places where it's 0. There's no like vertical lines on this one. So it's 0 there at -6, 0 at -2, 0 at 1, and a 0 at 7. So those are all the places where the derivative is 0 or undefined. Okay, so let's figure out, well, in this one it's just asking for critical values, so we're actually going to type all of those. But if we were to actually find mins and maxes, let's think about this would be positive to negative, so that would be a max. This would be negative to positive, so it would be a min. This would be positive to negative, so it would be a max. This one doesn't change. It is positive to positive. So there'd be no extrema there. So that's the one that's the critical value, but not an extrema. So that's why we say not all critical values are extrema, because that is one that is a critical value, but not an extrema. Again, all of these are critical values. So we're going to type in all of them. That one just happens to be the case. The function is increasing, and then it just levels off for a sec, slope is 0, and then it keeps increasing. So we're going to type in all of these. So we need 4 of them at -6. Looks like -2, 1, and 7. Let's just do one more for good measure. You guys can do this on your own. Find all the places where there's relative extrema. So relative extrema, that's mins or maxes. So we're just going to be looking for changes from f prime goes from negative to positive, or f prime from positive to negative. In other words, where does f prime change signs? Or in other words, where does it cross 0? Not where does it hit 0, but where does it cross 0? All ways of getting there. So let's figure that out. Relative extrema here, because it goes from negative derivative to a positive derivative. Here's a positive to a negative. Extrema, boom. Here's another one, a negative to a positive. And last but not least, the last one is not a extrema because it goes positive to positive. So not an extrema. So the 3 places there would be -8, -5, and 0. All right, so with that, I hope you guys have a little better understanding of this. One key takeaway again is always identifying if the graph is a graph of the function or a graph of the derivative, or again, in the future, graph of the second derivative. Once you figure that out, then you can think about, well, what am I being asked, and how does that relate to whatever graph I'm given? All right, good luck.